One. For the second part of this lab, we're going to be working with the last of the three major rock classes. So 2 weeks ago, we worked with igneous rocks. These start out as melts. A week ago, we were working against sedimentary rocks. These are layered deposits. Now we're looking at metamorphic rocks, which form when another rock, a parent rock, is subjected to heat and pressure. So this first part here, I'm just going to have you look this up based on the reading. And then every metamorphic rock has a parent rock, or protolith, that causes it to change. And the four major agents that change that cause a rock to metamorphose are will be described in your reading, so I'll let you figure that out there. And classification of these rocks is based on mineralogy and texture. And so you can see that the second one, texture, is one of the most important characteristics of texture is whether it has a layered or non-layered texture. And one thing I've done starting this week is provided links to the textbook we're using this semester. So you can actually see a little bit of how these textures might look. So you have foliated textures, you'll have, I'll tell you whether the grains are visible, you'll have a non-foliated, and this also matters, this also play a role in whether or not you're looking at foliated or coarse grain or large grained. And you can see kind of a little, and there's really nice examples in this text. I've been really impressed by it. And then you're going to be looking at one, because all metamorphic rocks have a parent rock, first thing you're going to be doing is looking at the parent rock. For example, slate is derived from shale. As you look at a so you'll look at this piece of shale and just sort of like, and then look at a couple samples of slate down here and try to describe the texture, try to describe the mineral makeup. And what you're going to use for this is one, these pictures, two, your text, and then three, often the this sketch view will have, for example, this slate has very fine foliation. See lots of these little layers where it breaks off and cleaves off. These are actually cleavage planes of the minerals that make this slate up, all lining up with one another, allowing it sort of break off into these very beautiful thin sheets. And then I'll ask you to make a couple comments on how the slate looks different than the shale. And so the first class, it turns out each of these rocks has a way of metamorphosing into the other. So slate will eventually metamorphose into phyllite, and phyllite will metamorphose into schist. And no, I did not say a rude word. Schist will metamorphose into gneiss. And so in all of these, you're going to see what minerals you can recognize. On many of these, the minerals are fairly clearly labeled, but not all. And if you find yourself spending more than about 5 minutes digging around for a mineral in the crystal, in the rock, move on. I'll give you a big giveaway with slate. You're basically looking at clay minerals. You got a lot of this just so you get a sense of the textures, the sizes, the colors, the mineral makeup. That's what you're trying to do. And you're going to be doing this for a total of 8 different rocks. So you're also going to be looking at quartzite, marble, amphibolite, and serpentinite as well. And so I kept this fairly short because, yeah, you all suffered enough last week. I don't want to push anything on you that's going to cause any more suffering or stress. Then finally, for your discussion, I also kept the discussion very simple. So what you're doing for the discussion is you're literally based on your last name. This gets rid of the problems with people not knowing what group they are, and also the factor that sometimes we had a group last week that nobody seemed to do anything in, which was kind of a bummer. So in this case, your group determines just what you're looking up. And so you're literally looking up one rock, trying to find it on Sketchfab, and then answering 4 questions about it based on either your text or Wikipedia, which also has great information on every one of these metamorphic rocks. Once you're finished with that, you'll simply post on the other two other students, respond to 2 other students with whether or not your respective rocks will be found near each other, and then any other way your respective rocks might be related if they are completely unrelated, how far apart might they have to be? And this last one's kind of very open-ended. So as you can see,